Welcome to Mastering Solutions. This question, when you first read it, doesn't seem like it gives you a lot of information. So let's go through and write down what they do give us. And this question, they want to figure out what the angle is between the central maximum and this first m, of course. So the equation is given to us in the book for this exactly. Now they say two narrow slits, so it's going to be a double slit equation, of course. So the equation given by the book is going to be sine of the angle is equal to m times lambda over d. So really the whole point of this question is just to emphasize this equation. And so it's kind of confusing though sometimes when you first look into it, because like we said, it doesn't seem like they give us a lot. They tell us that lambda is something. They don't give it to us, right? But they tell us that the slits are spaced 20 wavelengths apart. So for every one of these, we have 20 is the d. And they tell us, of course, that m is equal to 1. So when we plug these in, sine of the angle is 1 for the m. And then for lambda, we know that for every one wavelength, d is going to be 20. So really, it doesn't matter what these numbers are, because as long as we have this ratio, if we have 5 here, well, then we're going to multiply 5 times 20. So we'd have 100. This is the most simplified form of this fraction because it's just a ratio between these two that they're giving us. Of course, 1 times 1/20th is 1/20th, so we can get rid of this just for simplicity. And then to isolate the theta, we're going to have theta is equal to the inverse sine of 1/20th. So let's go to our calculator and we have inverse sine of 1 divided by 20, and that's going to give us 0.05. Now make sure your calculator, of course, is in radian mode. If it's in degrees, it will be wrong. So if we have inverse sine of this, that's what the degrees is going to be. And so that's obviously not the correct answer because they asked specifically for radian. So make sure that your calculator is in radian mode. Now, when we go back to here, so we have our answer 0.05 radians. Okay, so that's the answer. But I do, for practice, want to go over again how to convert radians into degrees because it comes up quite a bit. And so it is helpful to always take the practice to do that. We have 0.05 radians. We know that for every 180 degrees, we're going to have pi radians. Now the rads are going to cancel. And so we have 0.05 times 180 over pi. So we have 0.05 times 80 divided by pi. And that gives us, of course, 3 degrees. So you can see that when we had it in degree mode, it gave us the answer, but this again is just practice to go from radians into degrees this way as well. And so we have 3 degrees, but they ask it for radians, so 0.05 radians is the answer.